February 13th, 1945, 11:47 p.m., Dresden, Germany. Obergefreiter Klaus Hartmann crouches in the rubble of what was once a telephone exchange, his fingers trembling as he strips copper wire from a shattered switchboard. Above him, the night sky pulses red and orange. The Allied firebombing has turned his city into hell on earth. But Klaus isn't looking for shelter. He's looking for metal. Any metal. His unit's field radio died 3 hours ago. Without it, they're cut off from command, blind to enemy movements, and stranded in a city that's burning to ash. The problem isn't the tubes. Miraculously, those still work. It's the capacitors. Every single one has failed. But here's what makes this moment truly desperate. Klaus knows that even if he reaches the supply depot on the other side of the Elbe River, there are no replacement capacitors waiting for him. None in Dresden, none in Berlin, none anywhere in Germany. Because by February 1945, the Third Reich had run out of the materials needed to make them. The copper, the aluminum foil, the specialized paper, the rubber insulation, everything that makes a proper capacitor work had been consumed by 5 years of total war. And so German radio operators like Klaus were forced to use something that sounds absolutely insane: glass jars wrapped in aluminum foil and filled with salt water. I'm not making this up. This actually happened. And the story of how the most technologically advanced military machine in Europe was reduced to building radios out of kitchen supplies tells us everything we need to know about the final collapse of Nazi Germany. But to understand how they got here, we need to go back to when German radio technology was the envy of the world. September 1st, 1939, the German Wehrmacht crashes across the Polish border with a speed and coordination that stuns the world. Blitzkrieg, lightning war. But what makes Blitzkrieg possible isn't just tanks and aircraft. It's communication. Every Panzer company has multiple radio sets. Every Stuka dive bomber can coordinate with ground forces in real time. The Polish army, still relying heavily on telephone lines and motorcycle couriers, simply can't respond fast enough. Within weeks, Poland falls, and at the heart of every single German radio, in every tank, every aircraft, every command post, are capacitors. Now, if you're not an electrical engineer, you might be wondering what exactly a capacitor does and why it matters so much. Think of it like this. Electricity flows through circuits, but sometimes you need to store a little bit of that electrical charge temporarily, like a tiny rechargeable battery that charges and discharges millions of times per second. In a radio, capacitors help filter signals, tune to specific frequencies, and smooth out electrical noise. Without them, your radio becomes static and gibberish. They're absolutely essential. And in 1939, Germany was making some of the finest capacitors in the world. The Telefunken factory in Berlin was producing capacitors by the millions. Siemens facilities in Munich were innovating new designs. These weren't simple components. They required precision manufacturing, high-quality materials, and skilled workers. A typical military radio might contain anywhere from 20 to 50 capacitors of different types and sizes. Some were paper capacitors, made with thin aluminum foil separated by wax paper and sealed in metal cases. Others were mica capacitors, using thin sheets of mica mineral as the insulator. The best ones used ceramic materials that could withstand high temperatures and voltages. All of them required materials that Germany would soon struggle to obtain. By 1940, German forces had swept through France, the Low Countries, and Norway. The Kriegsmarine was prowling the Atlantic. The Luftwaffe owned the skies over Europe, and every single ship, every aircraft, every tank column depended on radio communication built around those precision capacitors. The German war machine was humming, but so was German industry, and the demands were becoming impossible to meet. Here's where we meet one of the unsung figures in this story, Dr. Wilhelm Ruf, an electrical engineer working at the Lorenz Company in Berlin. In early 1941, Dr. Ruf receives a directive from the Reich Ministry of Armaments. It's brief and chilling. Find alternative materials for capacitor production. Aluminum supplies are being diverted to aircraft manufacturing. Copper is needed for ammunition. High-grade paper is in short supply. Can he develop capacitors using substitute materials? Dr. Ruf knows what this means. The war is expanding faster than German industry can support it. Operation Barbarossa, the invasion of the Soviet Union, is being planned for June 1941, and it will require radio equipment for millions of soldiers across a front that will eventually stretch from Leningrad to the Caucasus Mountains. That's over 2,000 miles. The scale is insane, and the Führer wants it all to happen in 4 months. Ruf begins experimenting. He tries using lower-grade aluminum. The capacitors work, but their performance is inconsistent. He tries using zinc instead of aluminum. Better, but zinc is also in high demand for galvanizing steel. He tries different types of paper. Some work temporarily, but break down under field conditions. The heat inside a radio set, combined with humidity and vibration, causes them to fail within weeks instead of years. Every solution creates new problems. But here's what's really happening while Dr. Ruf hunts for substitutes. Germany's access to raw materials is being systematically cut off. The British naval blockade is tightening. Access to Asian rubber is gone. Trade with South America is becoming impossible. The occupied territories can provide some resources, but nothing like what Germany needs to fight on multiple fronts while also maintaining civilian production. By late 1941, the material situation is already critical. After 1942, it becomes catastrophic. June 22, 1941. 3 million German soldiers pour into the Soviet Union. The radio networks are working perfectly at first. Panzer commanders coordinate their armoured thrusts. Luftwaffe bombers receive targeting information in real time. The Wehrmacht advances hundreds of miles in the first weeks. But behind the scenes, the logistics are already breaking down. Radio sets are breaking faster than they can be repaired. Field maintenance units are cannibalizing parts from destroyed equipment. And the capacitors, those essential little components, are failing at alarming rates. Why? Because the Soviet Union is vast and brutal. Temperatures swing from 40 degrees Celsius in summer to -40 in winter. Dust, mud, snow, and vibration from constant movement stress every component to its limit. Capacitors that might last 5 years in a Berlin factory last 5 months on the Eastern Front, and there's no time to ship them back for repair. Soldiers need radios that work now today, in the middle of a firefight, with Soviet tanks appearing out of a snowstorm. This is where German ingenuity starts to become German desperation. Field technicians begin improvising repairs using whatever they can find. If a paper capacitor fails, they try to rebuild it using waxed paper from ration packages and aluminum foil from chocolate wrappers. I'm serious. There are documented cases of radio operators saving every piece of aluminum foil they could find because they knew they'd need it eventually. Some technicians tried using layers of silk or cotton fabric coated in wax or shellac as the dielectric material. It worked, sort of, for a while. But these field-expedient repairs brought only temporary fixes. The real crisis was building back in Germany, in the factories that were supposed to be producing new equipment. By 1943, after the disaster at Stalingrad and the relentless Allied bombing campaign, German industrial production was in chaos. The Telefunken factory in Berlin was hit by RAF bombers in November 1943. 40% of its production capacity was destroyed in a single night. The Siemens facilities in Munich were bombed repeatedly throughout 1943 and 1944. The specialized machinery for making precision capacitors, machines that took years to build and required skilled operators, was being systematically destroyed. And even when the factories survived, they couldn't get materials. Albert Speer, Hitler's Minister of Armaments, was performing miracles of resource allocation, but even he couldn't create aluminum and copper out of thin air. Every kilogram of aluminum had to be carefully rationed between aircraft production, radio components, field equipment, and a dozen other critical needs. The decisions became absurd. Should we build one more Messerschmitt fighter, or should we build capacitors for 500 radios? Both were desperately needed. Both saved lives. How do you choose? By 1944, the situation reached a breaking point. Dr. Ruf and engineers like him across Germany received new directives. Abandon conventional capacitor designs entirely. Use anything that works. There are no restrictions on materials or methods, just make something that can store an electrical charge. The normal rules of engineering quality no longer apply. Survival is all that matters. This is when the glass jar capacitors appear. The principle is actually quite old. It's called a Leyden jar, invented in the 1740s. One of the first ways to store electrical charge. You take a glass jar, coat the inside with metal foil, coat the outside with metal foil, and the glass in between acts as the insulator. Touch a wire to the inner foil, ground the outer foil, and you have a capacitor. It's primitive, it's bulky, it's fragile, but it works. German radio technicians in 1944 and 1945 were literally building Leyden jars to keep their communications equipment functioning. They used whatever glass containers they could find. Jars that once held preserves, medicine bottles, even laboratory glassware stolen from abandoned schools and universities. They'd carefully clean the glass, paste aluminum foil inside and out using whatever adhesive they had, sometimes proper electrical cement, sometimes just flour paste or animal glue. Then they'd fill the jar with salt water or wrap it in a grounded metal sleeve, connect wires to the foils, and seal everything with wax or tar to keep moisture out. The results were ridiculous by any professional standard. These improvised capacitors were huge compared to the tiny factory-made components they replaced. A proper military paper capacitor might be the size of your thumb. A glass jar substitute might be the size of a beer bottle. They were fragile. Drop one and it shattered. They were temperamental. The characteristics would change with temperature and humidity. They were inconsistent. No two handmade jars had exactly the same electrical properties. But they worked well enough to keep a radio functioning, and in 1945 that was enough. Imagine being a German radio operator in the final months of the war, opening your equipment and seeing these bizarre glass jars with foil and wires where precision components should be. It must have felt like watching your entire world collapse into absurdity. The army that had conquered France with gleaming modern technology was now held together with the electrical equivalent of duct tape and prayer. But here's what's truly remarkable. Even with these primitive substitutes, German communications didn't completely collapse. The radios worked after a fashion. Messages got through, commands were received, units stayed coordinated, at least until the very end. German engineering culture was so deeply ingrained, the technical knowledge so widespread, that even when the industrial base was bombed to rubble and the supply chains had completely broken down, individuals could still improvise functioning equipment from almost nothing. March 1945. The war is clearly lost. Allied forces are across the Rhine in the west. Soviet armies are approaching Berlin from the east. German cities are being bombed around the clock. And still, German radio operators are building glass jar capacitors, trying to keep their equipment running for one more day, one more mission, one more transmission. Klaus Hartmann, who we met in the burning ruins of Dresden, is one of thousands of technicians performing these desperate improvisations. The improvised capacitors tell us something profound about the final stages of Nazi Germany. This wasn't just military defeat, it was the complete exhaustion of industrial society. The Nazis had bet everything on a quick victory, on blitzkrieg campaigns that would be over before resources ran out. When that gamble failed, when the war dragged into its fourth year, then its fifth, then its sixth, the entire system began to cannibalize itself. First, they ran out of luxuries. Then they ran out of basics. Then they ran out of the fundamentals, the metals, the chemicals, the materials that make modern technology possible. And yet the improvisation continued until the very end. When formal production stopped, informal production began. When factories were destroyed, workshops in basements took over. When proper materials disappeared, substitutes were found. The German war effort in 1945 was like a machine running on fumes, held together by the sheer determination of individuals who kept fixing, rebuilding, and improvising even when the cause was obviously lost. There's a strange poignancy to this. These weren't evil scientists in some cartoon villain's lair. Most were just engineers and technicians, skilled workers doing their jobs under impossible conditions. Dr. Wilhelm Ruf survived the war and later worked in West German telecommunications. In interviews decades later, he described those final years as a period of constant crisis management, where every day brought new impossible problems that somehow had to be solved. He spoke about the glass jar capacitors with a mixture of pride and sadness. Pride that they'd managed to make it work at all. Sadness that it had come to that. The Allies discovered these improvised components when they occupied German facilities in 1945. Intelligence reports describe radio equipment held together with scavenged parts and improvised capacitors that looked like something from a mad scientist's laboratory. American and British engineers were simultaneously impressed by the ingenuity and horrified by the desperation it represented. Here was proof, in glass jars and aluminum foil, of how completely Germany's industrial capacity had been destroyed. Today we have capacitors smaller than a grain of rice that can do the work of those giant glass jars. Modern smartphones contain hundreds of capacitors, each manufactured to tolerances that would have seemed like science fiction in 1945. We don't think about them. They're invisible, reliable, and cheap. But in 1945, in a world torn apart by war, even something as simple as a capacitor became precious, irreplaceable, worth improvising from whatever scraps could be found. The story of German glass jar capacitors is ultimately a story about limits. There are limits to what military force can achieve, limits to how far technology can stretch when the industrial base collapses, limits to how long even the most skilled engineers can improvise when the fundamental resources simply don't exist. Nazi Germany learned these limits the hard way, and the evidence was visible in every jury-rigged radio, every improvised component, every desperate field repair using materials that would have been laughable just a few years earlier. So the next time you pick up your phone or turn on your radio, think for a moment about those invisible capacitors inside, doing their job flawlessly, manufactured by the millions in climate-controlled factories with materials sourced from around the world. Think about how different that is from a world where skilled technicians wrapped glass jars in foil by hand, hoping it would work long enough to send one more message, receive one more order, maintain contact for one more day. That's the difference between a functioning industrial society and one that's been bombed, blockaded, and exhausted into collapse. The gap between those two states is measured not in grand strategic decisions or battlefield victories, but in small components, mundane materials, and the desperate improvisations of people trying to keep their world from falling apart, one glass jar at a time. If you found this deep dive into the hidden technology of World War II fascinating, let me know in the comments what other obscure technical stories from the war you'd like to hear about. The collapse of Nazi Germany is full of these bizarre details that never make it into the textbooks, and each one tells us something important about how wars are really won and lost, not just on battlefields, but in factories, supply chains, and the hands of technicians trying to make broken things work just one more time